So our next speaker is Faseela from Ericsson. She comes from Ericsson Bangalore R&D India. She is the software engineer there, and she has been working with Ericsson for 3 years on the development of SDN controller. She's going to discuss how to improve the.
So this is the agenda. First, we'll see why we require a multiple controller architecture in SDN, and then we'll see the various factors affecting the open flow network performance, and then we'll look into handling dynamic network conditions like link failures, control channel congestion, and so on. And then I propose 2 solutions for dynamically migrating a switch from one control domain to another. It's basically a controller-initiated migration or a switch-initiated migration. So why distributed SDN controller? The answer is very simple. A single centralized controller lacks scalability. Firstly, the amount of control traffic destined towards this single centralized controller may increase with the number of switches in the network. Secondly, if the diameter of the network is large, no matter wherever the controller is placed, certain switches will definitely incur large flow setup latencies. And since the performance of the system is bound by the controller processing power, when the traffic increases, definitely the performance is going to decrease. Also, distributed SDN controllers are required for load balancing and fault tolerance. So these are the various performance factors affecting the open flow network performance. Flow arrival rate is the rate at which the packets enter the network. Flow matching is the time taken by an open flow switch to match an incoming packet to a corresponding flow table entry. And the control channel overhead includes all the control channel messages happening between the switch and the controller. Controller responsiveness is the time taken by a controller to respond to a particular open flow switch. And then flow installation cost is the cost of installing an end-to-end flow. And definitely, if you have multiple controllers, there is a synchronization overhead across the controllers. So the background for this study is some of the experiments I conducted on the open flow control channel behavior. I used a tool called OFNet, which is a troubleshooting and debugging tool developed by one of my colleagues. The tool is to be open sourced soon. So this is a topology diagram captured using this OFNet. So I started with a topology of 40 hosts and 7 switches with a single controller and did a simple ping. So the